Welcome to Brain Vision.
In this problem, we have sand that is being dropped into an empty rail car of given mass and at a given rate. We want to calculate the speed of the car due to the sand dropping on top of it. So this system gains mass, and here the sand drops vertically onto the rail car. So what this means is that the horizontal component of VI, the injection speed, is 0, since the sand falls vertically onto the car. Now, if we take the right direction as positive, we can write an expression for the velocity. So v, the speed of the car, is equal to vi x plus the relative velocity v di in the x direction. And so this is equal to 0 plus v di x. So we can simply see that the relative velocity v di, its x component at least, is equal to v. We also know that the mass rate of flow dm dt, dmi dt, is equal to 50 kg per second. And the mass m is equal to 2000 plus 50 t, so the mass as a function of time. Now, with all this information, we can apply our steady flow equations. So we know the sum of all the forces in the x direction, sigma fx, must equal to m dv dt plus v di in the x direction times dmi dt. And so let's substitute our values into this equation. Now there's no net force acting on this car, so this is 0. And the right-hand side is the mass m, which we said was 2000 plus 50 t multiplied by dv dt plus 50 times v. So here we have a separable equation. And the separable equation has the form dv over v is equal to minus 50 dt over 2000 plus 50 t. So we have a separable differential equation. To solve this equation, we'll integrate this equation with the initial condition that v is equal to 4 meters per second at t is equal to 0. So the integral from 4 meters per second to the final velocity v, which we wish to calculate, of dv over v is equal to minus 50 times the integral from 0 to t of dt over 2000 plus 50 t. So solving this integral, we get that the natural log of v calculated between 4 and v is equal to minus the natural log of 2000 plus 50 t, and that's evaluated from 0 to t. And so simplifying this, we get the natural log of v over 4 is equal to the log of 2000 divided by 2000 plus 50t. And so we can simplify one further, get rid of the logs on both sides, and we have v over 4 is equal to 2000 over 2000 plus 50t. So we can find the speed of the rail car as a function of time to be 8,000 divided by 2,000 plus 50t, and that's meters per second.